Hi class, how are you today? You know, you really need to eliminate that kind of thinking. Get it? Eliminate? Elimination? Huh? No? Okay. The learning target for today is to solve systems of equations using elimination. Again, this is the third of the three methods for solving systems, so it's the last method we're going to learn. So, for a scale, a 3, you can solve systems using elimination. 2, you can solve systems using elimination if both equations are in standard form. That'll be something x plus something y equals something, like 3x plus 4y equals 7. If it's in standard form, both of them, then you can solve them. A 1, I can solve systems using elimination if I don't have to multiply the equations. After they're in standard form, the first thing you have to do is you'll have to multiply the equations to get them the same. And you'll see that in a moment. So some of them you won't have to multiply though, and those are a bit easier. So if you can't do the multiplication step, but you can do everything after that, you're a 1. And you're a 0 if you cannot solve systems using elimination. Alright, let's get started. Alright, so here's the first problem. It's a system of equations. 3x minus 2y equals negative 7. 2x minus 5y equals 10. Now to do elimination, unlike substitution, elimination has to be in this form, where x and y are both on the left side of the equals sign, and the number that's by itself is on the right side. So if it's not in that form, you have to start off by bringing x and y to the same side. In this case, it's already in that form. So what we do now is we pick a variable that we want to eliminate. And so we either pick the x or the y. So it doesn't matter really which one you pick. Sometimes it's easier to pick a certain one. Usually it's the one that takes the less steps to change. So what we want to do here, I'll just, for the fun of it, pick the y's. So let's say I pick the y's to eliminate. So for the y's, the number in front has to be exactly the same, and the signs have to be different. So we need one positive and one negative. So in this case, we want to multiply both equations. So we take the entire equations and we're going to multiply both of them. But we're going to multiply them by different things. So first we say, all right, here's a 2 and here's a 5. What number can both of these numbers multiply into? This is very similar to finding common denominators when trying to add or subtract fractions. So if this is a 2 and this is a 5, well, they can both multiply into 10. So we want y to become, the number in front of y to become 10. So what do you have to multiply 2 by to get 10? Well, you have to multiply by 5. And what do you have to multiply 5 by to get 10? 2. Then, notice that these are both negative. So in order to change this equation correctly, we need one of them to be positive. It doesn't matter which one. For the fun of it, let's just say the top one. So that means we're going to have to multiply the top one by a negative 5. Instead of a positive 5. Now use the distributive property and multiply everything by negative 5 in the top one and 2 in the bottom one. So negative 5 times 3x is going to give you negative 15x. Negative 5 times negative 2y will give you a positive 10y. And negative 5 times negative 7 will give you a positive 35. In the bottom one, we have 2 times 2x, which will give you 4x. 2 times negative 5y, which will give you negative 10y. And 2 times 10, which will give you 20. Now that we have the two equations and these are opposites, same number but different signs, now we add the two equations together. So negative 15x plus 4x is a negative 11x. 10y plus negative 10y, well, those are opposites, so those cancel. They become 0, but they're gone. And that should always happen with elimination. If you do a problem and one of the variables doesn't eliminate, then you did something wrong. And you should go back and see what you did wrong. Because every time, these two should eliminate each other. Or if you chose the x's would eliminate. You should end up with just one variable after you add them. And now we add the 35 and the 20, and that'll give us 55. So now we've got negative 11x equals 55. So we divide both sides by negative 11. Using the division property of equality. And you get x equals negative 5. Now that you have x, you can go back into one of the original equations and solve for y. So now this is back to the steps of substitution. So we've got either equation, doesn't matter which equation you pick. I'll just go back to the first one, the very top. So we've got just blot that off. So 3x, but now instead of x, it's negative 5, minus 2y equals negative 7. So that'll give us negative 15 minus 2y equals negative 7, and then we solve for y. So negative 15 minus 2y plus 15 equals negative 7 plus 15. So negative 2y equals 8. Divide both sides by negative 2. And that gives you y equals negative 4. So we have our answers. X equals negative 5, y equals negative 4, which as a point would be the point negative 5, negative 4. So this is one of the more difficult problems you'll come across. A lot of times the variables may already be the same, and you might only have to multiply by a negative. Sometimes you won't have to multiply by anything. Sometimes you'll only have to multiply one equation by something. It all depends, but this is the more difficult kinds of problems that you'll end up with where you have to multiply both of them and change the sign. Alright, now time for the sponge. I want you to solve the system of equations using elimination. So you've got a system here. You pick either x or y to eliminate, and then solve for the variable that's left, and then go back and plug in that variable to solve for the other one. So that's it for this lesson. Once again, please make sure to take notes in the entire lesson. Attempt the sponge. Take a picture of all your notes and the sponge. Submit it all to your backpack. And have a good night.